Good morning. Today we are going to discuss about K-means clustering. K-means is a partition-based iterative unsupervised learning algorithm used to divide a dataset into K distinct clusters based on feature similarity. Each cluster is represented by a centroid, which is the mean position of all the data points in that cluster. K is the number of clusters you want to create. Then the centroid mu is the center of the cluster calculated as the mean of all data points assigned to that cluster. Then for the distance calculation, we are going to use the Euclidean distance. Next, K-means algorithm steps. First, we will be initializing the randomly selecting K cluster centroid. The next step, assignment. We will be assigning each data point to the nearest centroid forming the cluster. Next, updated step. After the assignment, we recalculate the centroid of each cluster by averaging the data points with the net. Next, we will be repeating the same steps until the centroid no longer changes or the maximum number of iteration is reached. So here we are going to solve the problem. So they have been given the 8 data points. So the 8 data points is mentioned over here. Here we are going to take the number of clusters as a 3. Then for the distance calculation, we are going to use the Euclidean distance. Then the initial centroid we are going to consider the for A cluster A1 we are going to take B cluster B1, C cluster C1. So this is the initial centroid we are going to take. So the first step, initialization, initial centroid we have been considered here. Then we are going to frame the table with the data points. Then the initial centroid, whatever we consider that we are filling in this row. Then we are going to calculate the cluster. So we know already Euclid distance formula for 2 data points. Okay. So this is x2, y2. This is x1, y2, y1. So the formula is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So by using this two values, this box will be filled. So to fill this box, the x2 value is 2, y2 value is 2. Then x1 value is 2, y1 value is also 10. So if you are applying in this formula, 2 minus 2 the whole square 0 you will be getting. 10 minus 10 the whole square 0 again will be getting. So answer is 0. Then if you want to find out this particular box, yeah, x2 y2 is 2 10 and x1 y1 is 2 and 5. So if you are applying in the formula, you will be getting the answer 5. Like that, you have to calculate the remaining values by using the same formula. So we have been calculated the remaining values with the help of this formula. So the next step, we are going to find out the cluster. So already we know in the KNN algorithm, we will be finding the data point to the nearest neighbor. So here also the same concept. In each cluster, we will be comparing whichever is minimum, that cluster only we will be finalizing. So here, in this particular row, the cluster 1 only minimum, so we have been chosen that as a final. So in this row, the cluster 3 only minimum, so we have been chosen that as a final cluster. Likewise, we have been filled the remaining. Next, we have to find out the new centroid. If you are looking for the cluster 1, we had only the A1 as a chosen cluster. So that is the centroid point for the A1. Next, if you are looking for B, so totally 1, 2, 3, 4, 5 times that is chosen. So all 5 data points we have to take. Then we have to take the average of all 5 to find out the new centroid. So these are all the data points. So 8, 4, 5, 8, 7, 5, 6, 4, 4, 9. We are going to take an average. So 8 plus 5 plus 7 plus 6 plus 4 for the x value. Y value 4, 8, 5, 4, 9. That and all we have been added and then taken the average by dividing the 5. So 6, 6 we got for the B cluster. Then for C cluster 2 times it is occurred. So average of these two is 1.5 and 3.5. Now again we are going to repeat the iteration with the step from the step 1. So iteration 1, the same type of table we have been framed with the data points. Now only the updation is new centroid we have been formed over here. So again, that new centroid, by using the same formula, that is equivalent distance, we can able to fill this 3 column. Then for this again we have to find out the new cluster. So in this particular row, first cluster only low value, so we have here in the new cluster we have been filled 1. Next for the second one, 3 only minimum, so 3 we have been filled. In the last one, 1 only minimum, so we have been filled 1. So now you just compare the cluster and new cluster, all values are same except the C2 data point. So if anyone is not matching also, we have to repeat the steps. So already we have been mentioned in the steps of the algorithm. Until both the clusters reaches the same value, we can stop the iteration. So that's what we are going to do. Now according to the new cluster value, again we are going to find out the new centroid. So by taking the average, so 1 is repeated in the 2 times, first and last. So 2, 10 and 4, 9, we have to take the average. Then for the 3, we have again 2 values, 2, 5 and 1, 2. So for that we have to take the average. Then for 2, we have 1, 2, 3, 4 values. For the 4 values, we have to take the average. By choosing that, we have been found the new cluster values. So that new cluster values will be centroid values will be filled over here. Again, we are going to calculate the distance by using the equivalent distance formula. After filling the data, now the cluster will be the new cluster in the previous slide. Next, we are going to calculate the new cluster again now with this value. So here 1, so 1, here also 1, so that only we have been filled 1. Now while comparing this two cluster is not matching. So again we have to proceed the same step in the next iteration by choosing the new centroid points. So with this value here, if you are looking, 1 is coming 3 times. So by using the 3 times, 3 values, we have been calculated the new centroid. 2 is repeated 3 times. By using that values, we have been calculated the B centroid. Then 3 is repeated 2 times. By using that, they have been calculated. So they have been updated the new centroid values. So now for the new centroid values, we are going to update the cluster. So now this cluster value is the previous new cluster. So previous new cluster will be filled with the cluster now. Now we are going to find out the new cluster. So this is the new cluster after finding the value. So if you are looking for row 1, 1 is the minimum. Here in the row 2, 3 is the minimum. Here 2 is the minimum. Here 1 is minimum. Here 2 is minimum. Here 2 is minimum. Here 3 is minimum. Here 1 is minimum. With that only we have been filled the new cluster values. Now you just compare the cluster and new cluster. All values are same. So now we have been partitioned the cluster properly and correctly. So we can stop the iteration here. So in the k-means algorithm, we have to continue the iteration until the cluster and new cluster value is equal. Until that, we have to find out the centroid values also. So next one, we have been plotted the diagram for that. Okay, so here we have mentioned the data points, the final cluster water we have been freezed, that we have been mentioned over here. So you know already how to plot the data points into the graph. Okay, like this we have been plotted all the points. Okay, now actually we don't know which cluster which points need to move. That is the reason we have been used the algorithm to find out the grouping of clusters. So here without this grouping, if you are looking this B1 point, it may be nearest to this point or nearest to this point. Okay, but we can't able to assume and then we can't able to group it as per our wish. So that only we have been used to the algorithm. So here the data point 1, that is 2 comma 10, so 2 comma 10, then data point b1, that is 5 comma 8, b1 5 comma 8, then the data point c2, that is 4 comma 9, 4 comma 9. This all comes under the cluster 1. So that and all we have been grouped together and mentioned the cluster 1. The same way, the next one we had a cluster 2, that is A3 8 comma 4. So 8 comma 4 A3. Then for cluster 2 B2 7 comma 5, B2 7 comma 5. Then for B3 6 comma 4, B3 6 comma 4 we have been made together as a single cluster and named it as a cluster 2. Next the last one, cluster 3. So A2, that is 2 comma 5. Then C1 1 comma 2. That together made as a group and named as a cluster 3. So here the k-means algorithm we are using for unsupervised learning data. So we don't have a label, we have just spreaded data. The data we have to analyze. Just like that, we can't able to group it. So by using the algorithm only, we are grouping with the help of the nearest neighbor. So here we are using the Euclidean distance formula. Initially we are choosing the centroid with the assumption. After that we are framing the distance values in the table with the centroid in the top mentioned and then data points in the left hand side rows. After calculating the distance, we are finding the clusters with the minimum distance whichever cluster is obtained. After that, we are comparing the each clusters with the new centroid calculation. If only one time the cluster occurs, that particular data point will be chosen as a new centroid. If multiple times it is occurred, we will be taking the average of all data points in that particular cluster. Then the average data point whatever we calculated, that is your new centroid for that particular cluster. So like that we will be taking the new centroid. Again we will be calculating the distance value, then we will be framing the new cluster value. So now we have to check the previous cluster and new cluster is same or not. If it is same, we can stop the step. If it is not same, we have to repeat the step again. So that time, whatever the new cluster value we are having in this particular iteration, that will be a cluster for the next iteration. Again with the new centroid value, we have to find out the new cluster. So likewise we will be repeating the iteration. Whenever the cluster and new cluster is same, we can stop the iteration. So that is the finalized cluster. Whatever the finalized cluster, for that this is the finalized cluster. Okay, for that we have to draw the diagram like this for the grouping of the data points. So this is the way the k-means algorithm will work for partitioning the unsupervised learning data in the machine learning. Thank you.